I'm Meredith Blackwell. I'm at the International Mycological Congress, the 11th one in San Juan, Puerto Rico. And I am here to talk to Dr. Frisvad. Hold up your...
Yeah.
And he is going to tell us something about how he grew up, how he got interested in fungi, and what his research is, because it's extremely interesting and hard research that has been going on for many, 3 decades?
Yeah.
3 decades.
Or 4.
Okay. 4?
4 decades.
Okay,
Yeah.
sorry. Okay.
Yeah, I was very interested in chemistry and mathematics when I was young, and so I started, at high school, interested very much in chemistry.
Where were you born?
I was born in Lyngby in Denmark, and
yeah.
I still live there.
Okay,
And-
and that's where you went to school?
Yeah,
School,
grad school. And then I considered the University of Copenhagen, but I thought that at the Technical University of Denmark I could be a chemical engineer using mathematics and chemistry. And when I started, my Master of Science project, I started with bacteria on cauliflower under modified atmosphere to see if the bacteria would destroy the cauliflower and whether this was a problem.
And
which,
did they?
But, yeah. But modified atmosphere really helped. But then my supervisor was going to the University of Copenhagen, or the agricultural university actually, and so I was very inspired by lectures by what was later my supervisor in PhD, Ole Filtenborg, and he worked on aflatoxin, and he talked enthusiastically about these different fungi that produce aflatoxin and so on. And so I was catched and I said, this is what I would like to work with. And I started with working on rotten apples. And now here, 40 years later, I'm back at rotten apples.
And there's more to learn.
Yeah, there's much more to learn. So it was a very nice start of my career because I was not a mycologist at that point. I learned a lot from Rob Sansom and Emilie Stolk and Martha Christensen, but in the beginning I have to be autodidact and learn myself what was all this mycology about. But I quickly found out that they produce a lot of fantastic chemical secondary metabolites, and I was one of the first to use those, at least in Penicillium and Aspergillus and that, for profiling of these. And I think this was a very important point in my career that I looked at these secondary metabolites because they are so species specific, and so I could actually recognize any one species by the profiler. Just by that.
What class of compounds are these that you're studying?
These are, we are studying all kinds of compounds, so polyketides, NRPSs, NRPs, terpenes, mixtures of those. Recently we are also work on nucleotide-based secondary metabolites, so that's really interesting, and they are very bioactive, but actually all kinds, whatever we could detect. And later in my career I got an Agilent award to buy very advanced chemical equipment, so we can now make mass spectrometry. But for many years I've been used to look at UV spectra using diode array detection, and then I can recognize a lot of those, but not all of them, but a lot of those. And meanwhile I got used to looking at these fungi, so just by looking at a colony I can sometimes say this is Penicillium expansum, no doubt. But then of course we verify it.
Yeah, so your secondary metabolites then really correlate well with molecular?
Yes, it does.
That's
beautifully.
Because it's not always that way with other organisms.
No, because I think I was lucky that we started with Penicillium and Aspergillus.
Yeah, you guessed
because
right.
because I know that Fusarium, for example, Alternaria, they can borrow some mini chromosomes when they're in heavy competition. So this makes chemotaxonomy in Fusarium more difficult.
Right.
But for Penicillium and Aspergillus, this is apparently not the case. They have a core secondary metabolome which is nearly the same, whatever isolate you get, whether it's from Australia or Denmark. But another thing I really was interested in and I worked on is the specific association of Penicillia and Aspergillus to different substrates. So and we really found out that
And so does
any one plant
substrate-
has these and these penicillia and so on.
Okay, does the substrate though influence the compound?
Oh, yeah, that too. But it's more this very strong association, say, between Penicillium expansum and apples, Penicillium italicum and citrus fruits and so on.
So
And this is more general than I originally thought. I thought it was only these plant pathogenic penicillia that were strongly associated. But if you look at litter, for example, it's always Penicillium yanceyevsky and Penicillium carnescens and so on, growing on the litter, destroying or degrading the leaves, I would say, producing these secondary metabolites, because this is a competitive environment. And so if there are competition selected and Penicillia are and Aspergillia are, then it's really then you can see a lot of secondary metabolites. So it's relatively easy to use this method to identify.
I'm curious about something. When I started graduate school at the University of Texas, there were a lot of people doing plant secondary metabolites.
Yeah.
There was a book by Alston and Turner. I don't know.
Oh, yeah.
You know,
Yeah.
yeah. And so I was always so envious that they could use these compounds, and I had nothing in fungi. And then you were doing it.
Yeah.
Probably a little bit later. Than
A little later, yeah. I started in '80.
Yeah.
To work, and we published the first paper, or I published the first paper and applied in environmental mycology on secondary metabolite, as for use in identification, apart from physiological characteristics like growth on creatine, agar, and things like this.
Yeah.
But this was more taken from zymology, with yeasts, because there you use nutritional tests, and they're also interesting. But I think secondary metabolites are so specific.
Oh, yeah.
And at some point, we with my PhD student Thomas Larsen, he's now professor also.
Right.
We worked on volatiles, and they were also species specific. Of course, they're also secondary metabolites. But so all in all, when we now look at genomes, full genomes of Aspergillus and Penicillium, we can see that they have all these maybe 70 putative gene clusters. It's amazing. and actually, we can only find 10% of them, being produced in any one medium. We have tried some tricks, like giving them some sodium chloride, and then they produce metabolites we never saw before. So there are simple tricks, and of course, more genetical tricks also.
Yeah. So how many media do you use?
It's very important for me to use a battery of media, not too many, but because we were also lucky that we got the right yeast extract in our media, because later we tried another yeast extract, it didn't work really. So we used this Diffco yeast extract, and for some reason this was fantastic for secondary metabolite production. So there must be something in yeast, after all, even though they don't produce secondary metabolites, that will help having several of these secondary metabolites being produced. But of course we'll learn a lot of tricks later, how to have more metabolites produced. And a compound like penicillin, you need a different medium, a different extraction method, a different way of analyzing it. So it's you cannot necessarily have all secondary metabolites in one run, in one extraction. So sometimes you have to take care of this also.
Do you have any of these unusual amino acids?
Yes.
Non-protein amino acids.
Yeah. Of course, there's alpha-aminobutyric acid, but also a lot of other strange amino acids that are incorporated into some of these NRPs, and it's really interesting to see that they can use the enantiomer sometimes, and LOD forms and so on of these amino acids, and produce the most bioactive molecules you can imagine. At one point, we found out that many of these antifungal compounds were also anti-cancer. So that was really interesting. Good old glycyrrhulvin is a quite effective anti-cancer compound. And so some of these have several activities. But of course in nature it's more because they're antifungal, or maybe they're attractors and chelators and so on. So they have a lot of functions, these, and are very important for the fungi.
Yeah, I never thought about that. But that makes sense. They're always talking about bacteria and fungi. The antibiotics are different because of the ribosomes. Do these work on ribosomes? Glycyrrhulvin, I don't know the action, the mode of action.
That's
ribosomes
no. It's actually working on the on the cholesterol and not so much this. It's something with the formation of the kernels actually. So It was called the curling factor also because it really inhibited botrytis and so on. Grisifulvin produced by, say, Penicillium yankshevsky or Grisifulvum.
And so you could see it in petri dishes?
Yeah, you can see this, yeah. What was also interesting was that an individual secondary metabolite like strorigmatocystin is all over the ascomycete.
The tree.
Yeah, in pesticides. So this was really interesting. Chaetomium, Aspergillus, but never in Penicillium for some strange reason.
Things that aren't closely related.
Yeah, exactly. Yeah. So the major point is you have to look for the profile and not for a single compound, because that might be misleading in a way. But the profile is never misleading. This is pointing towards a species.
Yeah.
Unfortunately, whatever the gene sequences is pointing to, the secondary metabolites and morphology is also pointing to, and enzymes for that sake. So they converge kind of, and you get these very clear species concepts in my eyes. You know, when I've seen one hybrid, but apart from that, never anything in between species. So they are in Penicillium and Aspergillus and Talomyces, they are clear cut. I really have to say that. It may not be like that in Fusarium, but in Penicillium and Aspergillus, it's clear cut.
That's sort of been a persistent theme of all the people I've talked to. They've had luck.
Yeah.
Your luck in picking that group. Well, you would have moved on. You would have found it eventually.
Yeah. You know, one other thing that in the beginning, my supervisor, Ole Filtenborg, he had this idea of using small TLC plates made from ordinary microscopic slides and put some silica gel on it and then look at the aflatoxin. But then we found this idea of placing an agar plug from a colony right on a TLC plate, just let it dilute. So we didn't need to extract or anything. It was such a simple method, and that was the reason we could screen so many isolates of Penicillium.
Right.
For example, 50, 100, 200 isolates of expansum.
You didn't have to handle all the mycotoxins.
No, not really. Except that, of course, they were on the TLC plate, but we didn't have to extract the chloroform and all this.
Get it in the air.
Exactly. Yeah. So this was a smart little method where we could screen a lot of isolates, and that was important for me to find out that actually it is species specific. And the reason I started with apples, or not the reason, but I started with these rotten apples, and I saw these very few species, and then I learned how much variation you can have morphologically in Penicillium expansum, yet it's pretty consistent in secondary metabolites and enzymes for that sake, and so on. So this was a nice way of learning how to, identify these fungi. And actually, I never use sequences. I use them as a backup or verification. But I start with physiology, secondary metabolites, macromorphology, micromorphology, and this is usually enough. And especially if you have more than one medium, not just PDA. We use this battery of media, and then I can recognize many of those. But of course, I will continue to use the different characters in order to identify.
It's good to have more than one set of criteria.
Yeah. Yes, you can be misled.
I was trying to remember the first meeting where I ever met you. Tampa, maybe, I think. Were you at Tampa?
No,
at IMC?
but I was at IMC 3 in Tokyo. Yeah, that was my first meeting ever.
Okay.
And first time I had to present in front of John Pitt and Rob Sampson and Carlos Ramirez and all those hot shots.
Did they get after you, or?
Not, but I remember that Lothar Leisner from Germany says it was a very nice lecture, but it was a little sweeping, because I think I must have said that chemotaxonomy is fantastic and could be used for anything, Maybe I forgot. But
you were young.
Yeah, I was young and, a little in opposition to certain mycologists, but we gradually agreed, and I was so happy that Rob Sampson invited me in '85 to join him, because we were so different. So it should be good when we, had so different opinions.
So were you at IMC4?
Yes.
Yeah, I was there too. So that may be the first time I met you, because I didn't go to meetings early in my career because I didn't have money to travel and I had a small daughter, and so it was really, really exciting when I could go and meet people like you and other people from other countries. So. Anyway,
Yeah.
thank
Okay.
you so
Yeah, that
much
was
for
nice.
talking to me. It's been nice.
This was
and,
so nice. Yeah.